And welcome, ladies and gents, to what I will call Chapter 9A. It's not really a chapter at all, to be honest. It's kind of a supplemental few lessons, several lessons to get us ready for the real Chapter 9 in our textbook. Today we're going to talk about unit rates, which I believe you have learned a little about before. So our goal today, I will find and compare unit rates. Now you look at $2.80 for 2 packs of gum, $7.98 for a 6-pack. Which of those is the better deal? Now, skills that we have learned in the past for this will include equivalent fractions, simplifying fractions. In other words, 15 over 36 is equal to what? But also converting between fractions and decimals through division. Sooner or later, we're going to get toward, in the purple, the percent of change problems and any other proportional reasoning problems, but that's where we started. The blue is where we're at, and the purple is where we're headed. Hey, I'm going to assume that you guys got this on Thursday, or I will see you on Monday. One way or the other, you need to, something very important. You're looking for the unit rate, but you're going to be asked, A, you may use a calculator. I hope I don't regret that choice. And B, you may round it to the nearest hundredth if it's necessary. If it goes on forever, if it does not stop, if it does not terminate, please round it to the nearest hundredth. And this is assignment number 1. More on that later, huh? All right, focus on the essential question. How can you show that two objects are proportional? I want you to think about what that word proportion means, if you recall that. And we'll talk about that more as we get along, but think about that question. How can you show if two objects are proportional or are not? Ratios and proportional reasoning. I'm going to read this out loud. You're welcome to pause, read it to yourself. Proportional relationships can be used to solve real-world problems. Now, in this quasi-chapter, not really a chapter, you will determine whether the relationship between two quantities is proportional. Then you will use proportions to solve multi-step problems. So that gives you a little more picture of where we're heading in the future, using it to solve problems. Unit rates, I have a great video. Not sure I'll be able to show it because of time factors. Maybe I'll find a way to share that. We shall see. Let's talk about what a unit rate is. Now, a ratio is any comparison of two things. A rate is a ratio that has two different units. So what I mean by that is if I say 6 red pens to 4 blue pens, that's a ratio. But as soon as I say 6 pens per bag, $6 per pen, 160 beats per 2 minutes. That is what we call a rate. So a rate is a special ratio. A unit rate is a special rate. A unit rate is where the rate is reduced to have a denominator that is 1. In other words, instead of writing 160 beats every 2 minutes, you could convert that to a unit rate and simply say 80 beats per 1 minute or 80 beats per minute. Now, we use unit rates all the time. Very rarely do you say, man, I traveled 467 miles in 7 hours. You're going to say something like, I went 50 miles per hour. Nobody goes to a car dealership and they say, listen, this car can get 732 miles on 15 gallons of gas. No, what they're going to say is, this car gets about 37 5/10 miles for every gallon that you put in. And that makes it much easier to compare when you go shopping for cars, which has the better miles per gallon. Dollars per pound is something we often see when going shopping. So right now I'm going to switch it over to a different kind of PowerPoint presentation. And we're going to talk about main idea, determining rates, unit rates in particular. And we just talked about comparing a rate and a unit rate and how those are special. Unit rate is a special rate, rate is a special ratio. And so here we go. So let's say Julia reads 52 pages in 2 hours. What is the average number of pages she reads per hour? Naturally, all you have to do in this particular case is go ahead and divide. So 52 divided by 2, 26. 2 divided by 2, 1. In other words, Julia reads 26 pages for each and every hour. Pause if you want. Go ahead and check this out. Come on back when you're ready. And if we were to go ahead, oftentimes I will many times write the units first. Question is having how many text messages per hour, so I write text over hours. Then I put 16 every 4, and naturally 16 divided by 4 will be 4 text messages per hour. All right. Find the unit rate per can if it costs $3 for 6 cans of soda. Once again, round to the nearest hundredth. We'll talk about that more as time goes on. Now, what's really important here, when it says unit price per can, you'll often see me again write the dollars per the cans. I often will write the units first. Then it's easier to put the numbers in the right place. We make sure to divide 3 by 6, not 6 by 3. 3 divided by 6 ends up being a half or 50 cents per can. And pause if you wish. Go ahead and come on back when you're ready. Again, we're looking here at price per pen. You'll see me write that. Meanwhile, we see that we have $8, 32 pence. $8 for 32 pens, you can kind of write divided by 32 divided by 32, or you can simply divide 8 by 32. I'm going to give you use of a calculator for today's assignment. One way or the other, sorry, I didn't write 32 there. One way or the other, it'll be 25 cents per pen, $0.25 per pen. Now, let's talk about how we use unit rates to compare things. We talked about going car shopping and wanting to compare miles per gallon from one car to one SUV. Got 3 runners shown. We're looking to find which one finished with the fastest time per kilometer. So examine one at a time. Time per kilometer, or in this case, minutes per kilometer, would be 6 8/10. Meanwhile, runner B, if we divide it out, would be 6 2/10. Runner C would be 7 3/10. Now remember what fast means in this case. Fast will mean the person who needs the least amount of time to run the same distance, and therefore, because this only takes 6 minutes to run the same distance, runner B will be the fastest. Now I find this example fairly interesting because usually we're comparing speed, in which case we would want the greater kilometers per minute. But in this case, we're comparing minutes to kilometers, so we want the least number of minutes. Pause, come on back when you're ready. And if you were to divide each and every one of these into their decimals, rounding to the nearest hundredth if you need. In this case, you'll find that Adam is going to be the fastest time per mile. All right, using a unit rate. So let's say we got an assistant cook peeling potatoes, 18 potatoes in 6 minutes. So at this rate, how many potatoes can he peel in 50 minutes? Now I got to tell you, one of the first things I'm going to do is try to find that unit rate. Just makes things easy. Naturally, 18 potatoes in 6 minutes would be 3 potatoes per minute. But we didn't ask how many in 1 minute. The reason we use that is now we use something that often in mathematics we call dimensional analysis. And that is, if you recall, when you multiply fractions, say for instance, 5 over 4 times 4 over 3. Sooner or later, you're going to reduce 4 in the numerator and denominator. We call this cross-canceling. Well, just as numbers can cross-cancel, so too can units. If I were to place 50 minutes over 1, not give any units at all, we can see very quickly that minute will cross-cancel with minute, leaving us with what? Only potatoes, which after all is what the question asked. In this case, 150 potatoes in that amount of time. Now we'll talk more. To be frank, I don't remember learning dimensional analysis until sophomore year chemistry class. But it has since become more of a standard in 8th and 7th grade classes to get students prepared for their high school science classes. So you'll see me probably do this a bit in the next week or month or half of a year. All right, pause, come on back when you're ready. All right, first and foremost, what's the question? How many beads? 45 minutes. But they don't give us beads in minutes in 45 minutes. They give us beads in particular here 21 beads in 7 minutes. So the very first thing I'm going to do is I'm just going to create a unit rate. Naturally, 21 divided by 7, 3 beads per minute. Of course, if you wish, you may put the 1. Now, question here says, 45 minutes. So am I going to put that in the numerator or denominator? If I don't want minutes, then I better make sure minutes crosses off. In other words, we're going to put it up top. Some of you just do this instinctively. Mr. Callan, I get it. 3 beads per minute, 45 minutes. Just multiply 3 times 45, and you will naturally get 135 beads. Folks, that's what I have for today. Bringing it on back. How can you tell if two things are proportional? I don't know if we talked about that really too much, but the key is that you set up an equality relationship and actually see, are these related? In other words, I forget the ratio we were just talking about. 150 words per 10 minutes, and then 15 words per 1 minute. That's how you know if two things are proportional, if they are in fact equivalent, if you divide out to the unit rates. Now, go on, you are allowed to use a calculator. Once again, I'm going to reiterate that if it is necessary, please do round to the nearest hundredth, front side and back side to this assignment. And that's all I got for today, folks. See you on Monday or Tuesday.